share this. So now you should see my presentation. Is that correct?
Yes, thank you. Thank you, Professor.
Okay, so you want me to start right?
Yes, right now we have the session chair. I am now requesting Professor Dr. Muhammad Shariful Islam, the chair of this session, to start the session. And I also request all the respected guests, participants, please do understand that one of our keynote speaker, Professor Tariqul Islam, is facing some technical difficulty, and that's why we had to alter the presentation session. Please be connected with us. We will try our best to make both these keynotes to be happen. Professor Dr. Shariful Islam, please introduce Dr. Thorsten Henkel.
Thank you, Professor Rajak. Dear audience, can you hear me?
Yes.
Yeah. Herewith, I am welcoming Professor Mr. Thorsten Henkel, who is currently heading the Industry Security Solutions team of Fraunhofer SIT based in Germany. Our today's session, the keynote will be on enhance your perspective, the IT security as an enabling factor for production industry. So let me introduce with you with Dr. Henkel. Actually, Dr. Henkel is, I just find him actually a combination of, it's a rare combination. He's at the same time an architect, a civil engineering background, and then he completed his PhD from computer science and architecture. So he knows different dimensions, and now he's working with Industry Security Solutions of Fraunhofer Institute of Security Information Technology, SIT. And he has been there for since 2001 to 2014. He was there in the Security Engineering and SIT test laboratory. Then till now, he's leading there as their industry test laboratory and industry security solutions research head. And he obtained his PhD in 2002 from Bauhaus University, Weimar. And I'm very happy to have you here with us, Dr. Henkel. And I'm requesting you to start your presentation. So it's over to you, Dr. Henkel.
Okay, thank you very much for the kind introduction and the chance to represent some part of our work today within your conference. At this place, it's early in the morning. I think you are at the afternoon, so I'm to some extent fresh, but I hope you are also in a position to follow the next 45 minutes. What I'm going to tell you is something about IT security from a German perspective. I'm going to talk about smart production. We call it Industry 4.0, industry with IE, not Y, because we think this is a German invention. And the main topic is IT security as an enabling factor for any kind of activity you do in the field of engineering and production environment. And then I would like to show you something about the recent finished UNO project, which was a huge national IT security project funded by the German government. And then I would pick some tiny little thing, the anomaly detection, in order to show you one result of this project. And this is the best way to show you what we feel may IT security provide for industrial production in the future. But first of all, let me start with some words about our institute. We are one of over 60 German institutes. Fraunhofer is a collection of unique single institutes with more than 25,000 employees in Germany. Our institute has around about 300 employees, and we are located in Berlin, Darmstadt, and Berlinghofen, which is pretty close to Bonn, the former German capital. But the headquarters is located in Darmstadt with more than 250 employees. And what are we doing? we're doing mostly everything that you can't imagine about IT security, beginning with advanced cryptographic engineering, about secure software engineering, security management, cybersecurity and analytics, some test lab environments, and recently founded post-quantum cryptography department. And we have two directors. The first one is Professor Michael Weidner, who is the director of this institute for around about 10 years. Before that, he was the strategic officer of IBM, responsible for IT security worldwide. And his deputy director is Dr. Markus Schneider. And together, we developed Darmstadt as a melting point, a European melting point for IT security and all the activities around that. But let me tell you something about Industry 4.0 as the German and the European community experienced that. You may or may know or have heard about that we don't produce in Germany and especially in Europe any longer in a traditional way. This is a steel mine which is deserted, and the only thing we have to cope with the market of the future is to become a high-end industrial production country. And this means we have to have IT within any kind of system that we provide for the production environment. And that was the foundation for the idea of Industry 4.0, which meant that every single production process, starting with the idea, the design of a product, the construction of a product, the realization, the usage, even the maintenance and the recycling, shall be a process which is entirely based on IT dedicated systems. What does that mean? So there are a lot of levels of Industry 4.0. The shop floor level is populated with smart machines who know something about themselves. They have an identity. They integrate themselves, they can communicate with each other, and they share a lot of information across the machines, but across company borders as well. This is the field of the cyber physical systems, which is enhanced of the level with the intelligent product, which has also new features like an identity, a production path, a history, some knowledge about the place of its current production and the condition of its own production phase. This is the level of big data. A lot of data will be created within that level. And finally, on the top of that, you have a cloud-based level that provides engineers systems that help people to produce these products at the one time, but also interfaces for customers to create a tailor-made product that can be ordered in the cloud area, created in the big data environment, and downgraded right down to the shop floor level in order to be produced as a unique product. Along this route, you have to fulfill something. You have to have a vertical integration of all these data, from the collection of the data down to the operation on the shop floor level. But you have to have an integration in a horizontal way as well, because we call the new world of today of Industry 4.0 the world of competition, which means the competitors of today are competitors of tomorrow, but they will work totally cooperative in a way that they share all the environment that is applicable for construction purposes. At the end of the day, you will have a unique customer tailor-made product, which is made on competitive cost models. It's on customer demand, designed. It is very highly optimized as far as CO2 footprint is concerned. It's adaptable to agile market changes. And at the end of the day, it's a very ergonomic product, not only the product itself, but also the machine that is used within the production process. The idea behind that is that you can help the elderly people in a longer time in the production process, and you can attract younger people to join the production environments because it becomes a smart environment, and it feels like working for Google or Apple or all the other fancy companies. While doing that, we have to take into account that every kind of data, especially when data becomes a value of itself, the new oil of the internet, of the production environment, because some newer business models and business products will be based on that, we have to face that there are some critical points while using all these open oriented communication processes. What you see here is an interface of a Shodan system, which is a search engine. It's comparable to Google, but this is especially dedicated to PCL and SPS systems. So every production system that is connected somehow to the internet and is broadcasting any kind of information across the internet can be found, identified, and located with this Google search engine. That is very, very risky, because you can learn something about the sites. And if you take place in a market like that, you have to have security, because you want to do things like protecting your intellectual property, but also you want to have a business continuity model that keeps you running and keeps your systems running. And what you see here is a damage in a German steel mill that had been faced a couple of years ago, based by a cyber attack which came across the internet mail system. Someone clicked on something, and this had the consequence that the whole steel mill was shut down for a couple of hours. And the special thing about a steel mill is that you can't reset that. Once a steel system has been shut down totally, you have to rebuild it right from the scratch. So that was a big, big damage caused by a tiny little click on an email attachment. So we have a lot of damage based by IT security incidents, and there's a lot of things ongoing around this today. This is a quite old study of the Indonesia protection, covering the actual status of protecting industrial control systems. But today the picture is nearly the same. There are a lot of things available, but very few of them are implemented or in use, which means most of the systems are not protected against IT threats and cyber attacks right now. But you have to have it in order to have fun while being a part of the market. So what does that mean? IT security is always a triangle between assets, threats, and trust models. If your assets are low, then you have to do nothing because your risks are low. If your assets are big, you have to do something, but there are thresholds you can't exceed, because even if you would never put all the money you have to protect your assets. You will never take $1 million to protect an asset that is worth $1 million, because then it's not logical. There are technological thresholds you can't achieve because some technology is not available right now. So there are residual risks you will never face. And there are uneconomical action items you will never be able to face because you don't have enough money to do that. And there's unavailable technology. But what you can do is you can focus on this quadrant where your assets are, and you can identify what's the value of my assets, what is my economical threshold, what are my residual risks, and what are my acceptable risks. And if at the end of the day, you create something like a security policy that helps you to make the right decisions. But let's take a look at the IT security as it's perceived today. In the past, security was an add-on. It was done with patches. Something happened, someone reacted, someone scheduled a patch, and you had to revise the system in a way that solved the problem somehow. Then the next step was security by design, which was an approach which is currently today used by creating software and hardware components, which means you have a secure software engineering process that starts right from the scratch by thinking of security, and security becomes a dimension of product quality. But this is even enough for, it's not enough for today. We are living at the Industry 4.0 environment with all these challenges, and what we have to have is security at large, because even if you have a secure software engineering process with security by design and produce a secure single product, you have to connect it to other products, and they may or may not be secure or insecure. And this can do some harm to your normally secure model or product in a way that you haven't expected before. So what we do need is security at large, which means that you can move, act, and behave in an unsecure environment in a very securely way without thinking about all these insecure things around you. And that's the way we would suggest to do things. And the thing we use to achieve that is artificial intelligence, or let's say, we can't talk about artificial intelligence today, but we have some kind of machine-based learning approaches that helps us to make decisions. And I will show you some of them later in the presentation. But first of all, I would like to introduce the German UNO project, as I mentioned at the beginning of my presentation, which has been recently finished in one year ago, at the autumn of 1 year ago. And that was the biggest national reference project for IT security in Germany for years. It covered a budget around about 50 million euros, and we had more than 20 partners from big German industries who are facing altogether the anticipated risks of IT security within Industry 4.0 of the future. The idea was that we have at the end of this project a toolbox or a set of tools that help small and medium companies to enhance their IT security ecosystems in order to get Industry 4.0 ready. And that's the reason why only big players are part of this consortium. The idea of the government was that only the big players are wealthy and powerful enough to create some kind of toolbox within 3 years that is directly applicable for the small and medium enterprises. And that was a good idea. And the next good idea was not to create some new models for Industry 4.0, so some new reference models. The idea we had was, let's make 4 demonstrators with dedicated topics. And we did that. We created 4 of them. The first one was about individual production, the unique tailor-made product. The second was, what about the data that will be created during this process, how to share that, how to base new business models on that, and how to protect it. The third one was, how can we have remote control for all these spatially distributed working systems and computer components? And the last thing was, how can we control that agile, widespread thing in a real-time approach by means of this toolbox things? We based on some methodological approaches. I already mentioned security by design, but we had the idea to create new encryption architectures for this new approaches as well, and we did that. And as far as the individual production is concerned, we created digital identities for the products, pirate protection, and so on and so forth. On the secure data environment, we secured transmission. We had some ideas of digital rights management for data and product data. On the service level, we had secure ad-hoc networks, environments, and the virtual security dashboard. And that is the topic where I give you an example of the results of this project. We tried to get access to some new approaches like anomaly notification in production systems. this is the example I want to show you, because I mentioned before that we live in an agile, worldwide spreading production environment. We have to have artificial intelligence in order to achieve security at large. But this is a tricky thing, because most of the production sites are running for 20 or whatever years, and a couple of systems used there are legacy systems, and you can't equip them with the high edge and bleeding edge technology of today, because it's not available. And if you would create that, they are not ready to cope with that. So you have to think about how to integrate those systems without applying new technology. And the idea was to collect the data, the whole of the data produced by all these systems while running, and to have an anomaly-based detection system for IT security issues. And what we did, we made a prototype of that. And there are some kind of approaches that are already known. We have host-based systems that anomalous host systems, like Tripwire, Verisys, or Oasis. And we have network-based systems like NITES, you may have heard about Snowd, or security, who are able to scan networks for anomalies. And we have hybrid systems. And all these systems have different approaches in order to identify anomalies. The first one is signature-based, which means you have to train the system in order to identify an anomaly. For those who have had some picture collecting systems on the computer, you may have you may not know these systems already, because some of them provide the idea to collect faces. And they can train the system to collect all the faces that are dedicated to your wife or to your children. And the system in the background can dig all the wide number of pictures you have and identify the face of your relatives, of your family in any kind of this picture, and can sort the pictures to the person you recognize. This is an anomaly or a signature-based system. And this is a machine learning approach, which is called, to some extent, a supervised approach. This is highly efficient, but it means that you have to have an expert in order to train the system. That was not the thought of thing we would like to have. We thought it would be better to have an unsupervised approach, which means collect all the data from the beginning of the system without knowing too much about the environment, which is pretty close to the Industry 4.0 approach. You don't know too much about the system you are interacting, and you don't know too much about the system of your partner, but you want to have a system or a dashboard tool that helps you to scan and to track the IT security level of your working systems in real time, without having too much knowledge and too much expert training within the system. So there are those machine learning types, the supervised, the unsupervised, and some others. And we voted for the unsupervised learning systems, and we created a kind of prototype environment, taking all this data from the shop floor level by collecting that from the TCP/IP environment, from the BACnet environment, for the Koenix environment, whatever, and collecting that with Kafka-based tools who had an Hadoop database connected to a Docker environment, which took a high-5 environment in order to analyze all these data. And at the end of the day, we used a Spark UI in order to provide all these information to the security dashboard. And this allowed the people to have a feature selection and an algorithm selection that helped people to separate the collective information from the shop floor environments in order to identify which kind of information is necessary and useful, and which one is not. And we used a very well-known anomaly detection approach, which is known from analyzing documents. There's the latent Dirichlet allocation system, which was created to scan a document. You can by using this approach, you can scan a document which is dealing with two different topics, and this approach helps you to collect all the words that are dedicated to the topic A and all the words that are dedicated to the topic B without the knowing what the document is about. And the words are the aggregations, and we said, okay, we can use this and regard the words, for example, as IP addresses, and we trained this approach in order to analyze and evaluate the shop floor based information collection. There are a lot of challenges today as well, as far as that is concerned. We have although you don't have to have a label, it's very, very challenging and demanding to get access to the network data. The protocol level is very, very heterogeneous. So we have to have the expertise and knowledge of a wide scope of standards and protocols, UPCOA, CONNEX, BACnet, whatever. And you have to capture all these data, and you have to have a real-time network stream in order to analyze and evaluate everything. Anyway, at the end of the day, you have a lot of false positives as well. So there's a lot of work to do, but we were successful to create that and to use it as an anomaly detection demonstrator, which allows us to identify the IT cyber threats and attacks and separate those from the anomalies which came from the normal usage of the system. And at the end of the day, we put that in a UNO tool. I mentioned before that the idea of the UNO project was to create from these approaches some tiny little tools that are tailor-made to be directly equipable for the small and medium enterprises in Germany. And the tool what we created was an anomaly detection desktop tool, which are represented all the data collected on the shop floor level in different ways in order to be aggregated for the person who is running the machines on the shop floor level at the one time, but for the management environment who has to learn something about the performance of the system at all at the same time. So those are screenshots from the demonstrator, who is currently a part of the VW German car manufacturing company with one of their production sites nearby Wolfsburg. It's pretty good performing at the moment, and they are planning to redevelop it to our production sites too, that they are going to use worldwide. So the next thing, what we want to achieve to have this information as a daily routine within the shop floor level environment. And we are on a follow-up project currently working on putting all this information into a smart augmented IT security environment system for the technician who is working with the systems on the shop floor level. And he will have something like Google Glasses or a tablet or whatever in order to get all these maintenance and IT security information directly down to the shop floor level, because it's one success to know everything what is going on inside your production environment on the data dashboard environment, but you have to have the personnel in place on the shop floor area that can react on that very quickly and fast in order to fix the problems. And the reason or the problem behind that is that these people are totally non-IT security specialists. So you have to have something that helps them to do something very high sophisticated on a technical level that is dedicated to the shop floor environment. And that's the next big thing we are dealing with, is to transfer all these toolings from the shop floor real-time environment into the digital twin, digital shadow environment of the Industry 4.0 IT dimension. So that's everything for today I wanted to tell you. So I've represented you something about the Institute, something about our understanding of IT security within agile, huge agile, worldwide spanning, spatially distributed working environments. IT security as an enabling factor, because you have to have it. You have to be sure that you can protect everything, your intellectual property, the products you create. You have to be in the position to prevent piracy for your products. And if you have that, you are free to do everything what you can imagine to do or what you feel entitled to do. And then it starts making fun being part of the production environment. And that's the way we want to support you. We want to support you with IT security as an enabling factor. You should have fun while doing things you like to do and shipping the products you want to ship. And we help you to do that in a very secure and safe way. Thank you very much for your patience and for listening.
Thank you, Dr. Thorsten Henkel, sir, for your presentation, resourceful presentation.
So I will stop sharing.
Okay.
My screen. Okay, thank you. Are there any questions? I could.
Yeah.
So
thank you, Dr. Henkel, for your nice and informative presentation on the current trend in security, especially security for industrial products and for Industry 4.0. So may I now request the audience to come up with any questions you have?
Now, I would like to request Honorable Session Moderator, Professor Dr. Rahmatullah Khandokar and Dr. Mohammad Amin Rahman Sir to represent certificate of contribution to Honorable Keynote Speaker Dr. Thorsten Henkel for his invaluable keynote speech.
Okay, the reporter, actually, we do have the question and answer session. So should we continue the question and answer session first? The QA session, hello?
Yes, sir.
Yes, please let me finish the QA session first. Okay, sure. So if there's no questions from the audience, let me ask a few questions to Dr. Henkel. You rightly pointed out, and even I do teach security, and I also tell my students that it has been a problem that security has always been an afterthought, right? And in your presentation, you already showed us that at first it was like security by patches, like add-on. Yeah. Then it comes security by design, and now you are considering security at large. But in a country like ours, I mean, we are having difficulties in motivating and making the industry and government understand that it's not the time to think security as an add-on. We have to think of security as a design, at least for our part in this world. I mean, Bangladesh. Though you are thinking as security at large. So how do you actually, what is your suggestion? What will be our approach to motivate the industry so that they should think that security should be an integral part for the next generation?
Okay, we are facing the same problems in Germany and across Europe. It's very similar. if we talk to people from the production environment or production domain, and we are talking to them, we have to learn that they very often they don't know something about their assets, they don't know something about the threats, and they don't know how to protect something. But at the end of the day, they have an IT security budget. They are still doing something. They are spending money, but they're spending money without rhyme or reason behind. And they have a lot of money invested in some IT security systems. And what we can tell them is to optimize the environment. And that's the first step, to say, okay, you can save money with analyzing the situation of data or things to be protected, threats that are pointing at your assets, and the technological and process-oriented countermeasures. That's the first step, and that's very easy, because if you tell people they can get the double of value for the half of the budget, then they are easily convinced to do that, and that's the opener. But you are totally right. If you talk to the production environment and telling them you have to have IT security as a product dimension within your production or producing your products, then it's hard to talk to them. And the only people who are willing to do that, and I think that those are the survivors of the digital transformation, are those who have already noticed that the data created with their products is has at least the same value as the product itself. And some of the market participants have learned that lesson, like Trumpf, which is a laser cutting manufacturing environment. They are no longer selling their systems. They give it nearly away for free. They earn money with the software and the tools and the applications and the business models and the business enhancement that comes across with their product. And while you have switched your business model into that direction, you know that you have to have IT security because it protects your own product. And that's the foundation of your business model, and that's the foundation of the revenue. But I know, and it's totally agreeable, and it's true for at least 50% of the German companies as well. It's hard to talk to them and to convince them to follow that route. Most of them are currently highly performing companies, and they don't see the need to change their attitude of producing something. But there is no solution to that. As I know, we have continued to talk to them and to try to convince them.
Thank you. I think there's a question from Professor Atik from Japan. Yes, Professor Atik, please.
Yeah. Thank you for the nice presentation. I just wondered that in one of your slides on augmented IT security, you mentioned that augmented reality or mixed reality applications are not so much IT security prone, and also you don't need to give some training for this stuff. But I guess that for this kind of applications and to handle remotely, learning is needed for the staffs and the personals as well, and security will be a concern at the same time. What do you think about that?
Yeah, it's a good point. What we started to think about that while we were talking to the company I mentioned before, Trumpf, and they had the problem that they had staff on the shop floor environment who was not very well trained with everything. And when they started to maintenance their systems, and I talk about their physical maintenance to refill something or whatever, they had to have paper-based guidelines in order to do things. And they have their guidelines in the one hand and they have the tool in the other. But the idea was to give them the opportunity to do something with their hands without reading a guideline at the same time. And you are totally right. The system, you have to have some training to use this augmented reality things, but we have made some project with them, with our staff, shop floor staff who had Google glasses, and we could give them information about the machine and the IT security aspects of the machine as well. And they were able to manage maintenance and repair orders without knowing too much about the technology lying behind. Yeah, but you are totally right. You have to train the stuff on the level of using all these augmented reality thing, and all these augmented reality things as well have to fulfill some kind of IT security level at the same time, because you can even attack those systems in order to do some harm to the production environment. So it's a complicated approach. You are totally right, but we think this is one piece of the puzzle for the maintenance of the future of high-end production environments.
Oh, thank you so much. Yeah, I got it.
Okay, thank you, Dr. Atik. So, thank you, Dr. Hamstel, for your nice presentation. Just before concluding, I'm asking you to say something for the researchers who are doing research in the security field. As I have seen, have already developed a model like Anomaly Detection model, and that uses machine learning. So, do you think that this machine learning is needed for smart anomaly detection, and this can be a right field for the students who should work on security?
Yes, we think anomaly detection, we think machine learning approaches and artificial intelligence is one of the core things in order to achieve a new level or new dimension of IT security on two folds. It's a twofold approach. On the one hand, you can enhance the IT security tools itself by using machine learning based approaches. But on the other hand, you can use machine learning based approaches in order to scan and analyze the environment in a much more intelligent way. And the idea behind that is that you have such a huge and a big environment and a number of data that human individuals will never be able to cope with that on that level of engagement. So you have to have something, some back end system running behind that provides these decision-making approaches. And I think there's a lot of research stuff as far as machine learning approaches and artificial intelligence is concerned, and it will be highly needed in the future. And from my personal perspective, it's highly recommended to if you are interested in things like that, it's highly recommended to work in the field of machine learning and artificial intelligence.
Okay, thank you so much. And now may I ask the professor to do the next formalities,
please. Thank you. Thanks both of you, the respected rapporteurs, Muhammad Aisha Khatun and Muhammad Ahsan Habib, for hosting the keynote session delivered by Dr. Thorsten Henkel from Germany. My heartiest thanks to Professor Dr. Rahmatullah Khandekar, moderator of the session. Special thanks to our Honorable Chair, Professor Dr. M.D. Shariful Islam from University of Dhaka, for chairing the session and giving us his valuable time. Now the time to hand over the certificate to our distinguished keynote speaker and session chair. May I request now Professor Dr. Muhammad Shariful Islam to hand over the certificate to the keynote speaker, Dr. Thorsten Henkel, virtually as a token of appreciation. Please.
Thank you, Professor Amin. So here I'm presenting the certificate, the e-certificate to Dr. Thorsten Henkel, and again, thank you very much from STI. Thank you very much from Bangladesh for giving us your valuable time. So, certificate of contribution for Professor Dr. Thorsten Henkel. Thank you.
Thank you very much for everything.
Thank you.
Thank you. Thank you very much. May I request Professor Dr. Rahmatullah Khondokar from Germany to hand over the certificate to the Honorable Session Chair, Professor Dr. Muhammad Shariful Islam. Rahmatullah Khondokar, sir, can you hear me, please? Okay. I am very much delighted to hand over this certificate. Now I would request to receive the certificate, Professor Dr. Muhammad Shariful Islam, sir, please.
Okay, thank you, glad to receive this. Thank you.
Please, may I request